in the problem given, if Vi is positive, then V0 is negative. If Vi is negative, V0 is positive because the input is given to the inverting terminal. If Vi is positive and V0 is negative, then diode D2 is forward and D1 is reverse. If D2 is forward, V0 is, this is an inverting amplifier, so the output is minus of the feedback resistance by the input resistance into Vi. So V0 is going to be minus 2 Vi. But if Vi is negative, then V0 is positive, D1 is forward bias, D2 is reverse bias, so the output is going to be minus of 3K by 3K times Vi, which is minus Vi. Now, what in the present problem, Vi is given 2 volt. If Vi is 2, so the answer should be minus 4. The nature of the feedback in this circuit, so we have to find what feedback topology this circuit has. So the op-amp equivalent, op-amp basically is a VCVS. So this is the equivalent for an op-amp. Now, let's see how the resistors are connected. To the non-inverting terminal, we have given Vin. Say for example, this is the load RL. This is a load connected here RL. This is ground. And the 2K and 1K are connected in this fashion. 2K and 1K here. So if I join the ground nodes, the input is series and the output is in shunt. So if you connect input in series, the input resistance will increase by 1 plus A beta times and the output is going to decrease by 1 plus A beta times. So it is a voltage controlled voltage source, or rather we are mixing voltage at input and sampling voltage at the output. So voltage is the feedback topology used. you are asked to find the load current IL. As we know, op-amp tries to keep these two potentials same, Vp and this is also Vp. If you can apply the load method here, the sum of currents that leave a junction is 0. Vp by 1K plus Vp by 100 plus Vp minus V0 by 1K is 0. So we got Vp is V0 by 12. This is equation 1. So we can have one more equation here. Sum of currents that leave a junction is 0. Op-amp draws no current because the input resistance of op-amp is very high. So Vp minus of minus 5 by 10K, Vp minus V0 by 10K is 0. So Vp is V0 minus 5 by 2. From equation 1 and 2, we got V0 equal to 6 volt. So asked to find IL. What is IL? IL is Vp by 100 and Vp is V0 by 12 by 100. On substitution, V0 equal to 6 volt, we get IL is 5 milliampere. So IL is 5 milliampere, Vp is V0 by 12 and V0 is 6 volt. Find the value of the current IL that is flowing here. So if you see, the op-amp in negative feedback always tries to keep the voltage at non-inverting is equal to the voltage at inverting. So these resistors, two resistors here, they experience the same potential difference. The current here is 0.5 milliampere. 0.5 milliampere here, 9K, this is 1K, and the potential here is Vp, and this is also Vp. So when can we apply current division formula? You can always apply current division if two resistors are in parallel. Even if they are not in parallel, if they experience the same potential difference, they are ready for current division. Now, the branch current is 0.5 milliampere. This is equal to the total current into the opposite arm resistance by the sum. So what is IL here? It is 0.5 milliampere into 10 is 5 milliampere. So 5 milliampere is the load current.